So hello everyone, my name is Floor van Donkelaar. I'm from the University of Zurich. I'm their PhD student. I mainly work with Lucio Meyer. I work on galaxy formation evolution, mainly Milky Way-like galaxies. And I try to do this through like galaxy structure. So really like look specifically on globular clusters, specifically on the nuclear star cluster, etc., etc. I mainly do cosmological and body hydrodynamical simulations. So in my group, we have currently two. One is called GigaEras, which is a big zoom-in simulation. When it came out, it was the biggest zoom-in simulation of Milky Way-like galaxy. Probably not anymore. And we're currently working on Phoebus, which is similar to TNG 300, but just double the size. And that's medium res, and we want to go to a higher resolution. Yeah, and I also wrote on Skach or Sketch, I don't know how I call it, because I'm also part of the Swiss SKA part, which will mainly then be the Phoebus simulation for. So we really try to look at this hydrogen flow and stuff through the Phoebus for SKA. 1 minute.
Okay. Up next is Matthew. No, it's Matthew. Sorry.
Yeah, whoever finishes the 1 minute can press next, and then the person.
Hello everyone, I'm Andreas Berlind. I moved to the National Science Foundation about 1.5 years ago, where I work on extragalactic grants and data science AI programs. I will give you a presentation on Friday about funding opportunities at the NSF related to computational and AI related things, especially an upcoming AI Institute for Astronomy program that we're gonna do. But I wanted to just introduce myself now, tell you I'll be here all week, and if you want to come chat with me about anything NSF related, I'm happy to talk.
Oh, okay. Hi, everyone. I'm Matt Ho. I'm a postdoc at IAP. I'm interested in a variety of things, all things galaxy surveys, machine learning, simulation-based inference, interpretability. But one thing I wanted to point out in particular is something I'm very involved in is the Learning the Universe and Aquila collaboration. So this is a relatively new collaboration in which what we're trying to do is take advantage of all these amazing data science innovations that people have developed and apply them to real cosmological surveys. So this involves a whole bunch of people, many of whom are in this room, which work on subgrid physics and advanced cosmological hydrodynamical simulations, and a whole bunch of machine learning people who are trying to accelerate these simulations to give us realistic CMB and galaxy survey mocks, which we can then compare using other machine learning / likelihood inference techniques, either implicitly or explicitly, to produce constraints on cosmology. So I'm here to learn about all the wonderful things that you guys have done about this kind of step of accelerating forward models of galaxies. And I would love to talk to you about that.
And then up next is Diego. Thank you.
Hello, everyone. My name is Veronica Dornan. I'm a PhD candidate at McMaster University, being supervised by Bill Harris. And my research is looking into the relationship between the globular cluster system mass and the dark matter halo mass that's seen in pretty much all galaxies. Recently, I've been focusing on that at the very high mass end, looking at VCGs, but I'm looking to also investigate this for dwarf galaxies and also better understand how to determine which globular clusters are associated with host VCGs versus satellite galaxies, which are part of the intercluster medium. So I'm looking for a lot of different approaches to those kinds of problems, and hopefully I can talk to one of you to see if you have any ideas. So if you would like to talk to me about globular clusters, please do.
Thank you. After Diego is Amy.
Hello, everyone. My name is Diego. I'm a second-year PhD student here at UCSB. I'm part of the Enigma group. I kind of just recently switched into this group, so I guess now I'm interested in intergalactic and synchrogalactic medium and in the epoch of cosmic ray ionization. So a lot of high redshift quasar type of stuff, which is kind of cool to see some people working on not low redshift now too. I'm interested mainly in applications of machine learning and especially of simulation-based inference. Currently, I'm starting to work on a new project that is trying to use autoencoders to predict quasar spectral continua. as opposed to PCA, which is kind of the state of the art right now. And I'll be here for the entirety of the week. I mean, I live here, so I'll talk to you. Thank you.
Hi, I'm Amy. I'm a grad student at CU Boulder. My advisor is Julie Comerford. My pronouns are she, her. I don't think I put them on there because I suck. I work on identifying galaxy mergers in the Candle survey, and I'm doing this with a convolutional neural network trained on mock images from TNG50. So I'm really interested on how to better interpret physically what these neural networks are doing and the decisions that they're making and how that relates to astronomy. And then down the line, I'm also interested in using this catalog for some merger triggering of star formation and AGN work.
Hi, my name is Francisco Estander. I work in Barcelona. I try to work in too many things, more than I can. But so just in 1 minute, I would just say that I'm the main developer of the flagship simulations, the galaxy catalogs. And flagship is the simulation for Euclid. It's one of the largest embodied simulations, 4 trillion particles. We have developed a method to compute many galaxy properties, and we have a catalog of 3 billion galaxies with almost 400 attributes for each galaxy. That's 2 terabytes in our database for the catalog. And there are several plots about flagship here. Also, I've been running a program to do redshift calibration with the C3R2 program at ESO. And well, I'll be around if you want to ask me or talk to me. Thank you.
Hi, I'm Will Bowman. I am a postdoc with the Dragonfly telescope team. So I work primarily on the Dragonfly ultrawide survey, which is a low surface brightness imaging survey covering like 10,000 square degrees, overlapping with the Sloan Digital Sky Survey footprint. One of our main goals there is to find ultra diffuse galaxies out to low distances. Nice formatting. The other part of my life is developing SED fitting tools. So most recently using full photometric flux posterior distributions and seeing how that impacts galaxy properties that we get out of SED fitting. And I'll be here all week, so I'd love to chat.
Next is Chad. Thank you.
Okay. So, hi all, I'm Laura Scholz-Diaz. I'm a third-year PhD student at IAC in Tenerife. I work with Ignacio Martín Navarro and Jesus Falcón Barroso, and my main expertise is on galaxy star population, so I'm more of an observer here. And what we do is to try to probe the galaxy halo connection from an observational point of view. And what I did in my first work was to connect the scatter of the stellar to halo mass relation with galaxy ages and metamelicities that are obtained with optical spectra. So has the plot is here that's published in my first 2 papers. Also, we connect them with the star formation histories. And yeah, we find how the scatter correlates with their population properties. So I'm mainly interested to know how halo properties can influence varying properties of galaxies. And yeah, so I will be here again all week, and I will be happy to discuss further the galaxy halo connection on this week. So thank you.
Yeah. Up next is Yasuke.
Oh, hi everyone. I'm Chad Bustard. I'm actually a local postdoc here at KITP, so thank you all for coming to my building. I primarily work on things like the intersection between plasma physics and galaxy evolution. So how do things like cosmic rays, magnetic fields, and turbulence, how do they interact with each other and then have effects on large scale galaxy evolution? And there are a lot of long-standing mysteries in the cosmic ray field that I think could actually benefit from some help, or at least some clues from machine learning. So during this program, what I've been doing is I've been taking simulations I've run of pure MHD turbulent box simulations compared to ones with cosmic rays included with different cosmic ray ratios, different like transport physics, to try to see what imprints the cosmic rays have on turbulence and whether neural nets can detect and classify these imprints. I'm also working on using a UNet trained on these same turbulent simulations to try to generate other fields like, how do we paint the magnetic energy or cosmic ray energy on density slices? So thank you.
Hi everyone, my name is Isuke. I'm a PhD student at CMU, Carnegie Mellon, advised by Rachel Mandelbaum and Francois Lanous. And lately I've been focused on producing fake hydrocents with machine learning, and namely with geometric deep learning. And we model the cosmic web as a set of graphs here and use GANs to generate fake hydrocents. So the hydrocents are generated given a n-body simulation. And up there is what I have been doing lately. So it's doing a score-based diffusion model on manifolds. Specifically here, I'm showing on a SL3. So given like two random Gaussian blobs, it kind of learns this space. But this eventually is going to be, eventually the main goal is to use it for galaxy orientations and to produce hydrocents. Thank you.
Hi, yeah, I'm Pablo. So I'm a postdoc at Montreal and CCA in New York. I put some of my papers here in case anyone's interested in chatting more or in case they spring any ideas. So I've worked on tensions in cosmology and methods to clarify if two data sets are in tension or not. I've worked in Bayesian neural networks and how they can improve generalizability in SBI. I had a fun paper on training an AI to rediscover a law of physics, which is gravity. And we have a new method. This is a very new paper on how to validate SBI analysis on very high dimensions, which we're going to use for learning the universe, which I also work on. And also a new machine learning method for, again, inference in high dimensions, which we're very excited about as well. So yeah, if any of this is interesting to you, I'm here all week. Come chat to me. Thank you.
Okay, so hi everyone. My name is Hadi. I'm Pablo's friend, and I'm a master's candidate at the University of Montreal, MILA, and CLA Institute. And I've worked within the Learning the Universe collaboration, which aims to infer the initial conditions of the universe utilizing the power of machine learning. And a few weeks earlier, I presented a tutorial on probabilistic UNets in the virtual component of this program. And like there are deep learning tools to do Bayesian inference in high dimensions. And I included a link to the repository of my tutorial, which includes the recording and slides and like everything related to that. And I'm very interested to learn more about the astrophysical cases that like probabilistic units can be actually applied. So if you have a high dimensional inference problem and want to chat about like applying probabilistic units to it, I'll be more than happy to talk with you. Okay, thank you. Oh, just sorry. And more broadly, I'm interested to learn more about like areas in galaxy evolution that machine learning can make things faster and more accurate.
Thank you everyone that did a lightning slide. I think that's all of them. Cool. And then unless anyone else has anything to say, I think we'll see everyone back here at 4? No, at 4. At 4. Yes, at 4.